Hello everybody, this is a video about integers. I am your host Mr. Shirley, bringing the math like a boss. Now before you get started on this video too much, please print out the note that I've included in Google Classroom because we're going to be filling that in as you go through this, so it will save you a lot of time if you print that out in advance. Now, an integer, and this is written right on your note, is a whole number that can be positive, negative, or zero. And recall that a whole number is something that's not including decimals, not including fractions, things of that nature, but it can be positive, negative, or zero. Okay, and integers are often considered and used with a number line. It's one of the regular ways to help understand integers and how they relate to each other. So just as an example, if we were writing the number positive 5, we could just put a dot at that spot. Okay, yes, I know you could write it on the actual number line. It's up to you. I usually write it above. It's easier to write arrows and other things to indicate addition or subtraction or multiplication, that kind of thing. So I usually go above. If we were doing negative 8, for example, we could put a number above or a dot above the negative 8. You get the idea. We'll be using number lines off and on throughout this unit just to refresh things and give you a different way of looking at integers. If you don't like the number lines and you're comfortable without using them, then by all means don't use them. I will leave that entirely up to you. Come on, smartboard. There we go. Now, I would like you to fill in some of these blanks on your sheet as we go. The words in bold are already on your sheet, and then you fill in a little bit in there. So the arrows on each end of the number line, I'm going to pop back to that just so you can see what I'm talking about. So arrow on the end, arrow on the end. That indicates that the number line goes on forever. Okay? Yes, we're not actually going to draw that, but it's indicating that it just goes on forever, right? It does not stop at 10 and minus 10. Okay, it goes on to 100, 1000, infinitely. Okay, you will see that in other cases, such as graphing sometimes, things like that, when you're making an x and a y axis. Now, a positive integer is a whole number greater than 0, okay, and it's to the right of the 0 on the number line, just like we saw before. Mostly in math, up until this point, you typically would often use positive integers, okay? If you're not putting a sign on it, if you're not doing something specifically negative with it or involving a decimal or something, it is just considered a positive integer, so you use them all the time. All right, negative integer, surprise, surprise, is smaller than 0, and it's to the left of 0 on the number line. Okay, and yes, you always need to put the number smaller than 0 to the left, bigger than 0 to the right. It's just a convention. It's the way it's done, but always do it that way. Otherwise, you'll confuse me and other people and yourself. Now, is 0 positive or negative? The answer is neither. It's sometimes called a neutral number, but it does not have a sign one way or the other. It's not positive or negative. I have read things before suggesting that 0 is both positive and negative, but to me that really doesn't make sense, so we're going to stick with 0 being neither positive or negative. Okay, so again, please fill these things in on your sheet as we're going through. If you need to pause it, go ahead. It's a video. And if you want to just listen to my voice for a while, go ahead. I'm told I could bring on sleep in people, so you could play it before you're going to bed. Now, what two signs indicate whether an integer is positive or negative? I think you probably already know this one, but I'll put it up here anyways. So a plus sign for positive, negative sign for negative, and if there's no sign, then a number is considered to be positive. Okay, so if you don't write anything in front of it, and I'll just give you a quick example here. So that would be considered the same as this. Okay, so we have positive 5 with the plus sign here. 5 without any sign at all, so it's considered positive 5. Okay, so because like I said before, for a great deal of math, you're not really writing signs in front of what you're doing, and you generally will consider things to be positive numbers, so it would get really annoying to write a plus sign in front of everything that was positive. Okay, on we go. So two integers, the same distance from 0, but on opposite sides of the number line, they are called opposites. Okay, so we'll talk about those in just a second, but they are the same distance from 0. And this last bit is just, it's already on your sheet, but just to make the point clear, you probably saw it on the number line too, but the integers increase in value from left to right. Okay, so left is smaller, right is bigger. Okay, so find the opposite of each integer given below. I think this is on the second page of the note sheet that I wanted you to print off, but you should be able to just write those in there. So the opposite, like I said, is an equal distance from 0 on either side of the number line. So what that means is that it's going to have the same value, same numerical value there, but it's going to be the opposite sign. Okay, so the number is going to be the same, sign will be flipped. Okay, so for example, negative 14 would be positive 14. So why don't you take about 10 seconds, pause the video, and go through these last three and see how you do. Okay, I'll assume you did that. So positive 7, opposite is negative 7, negative 572. The opposite is positive 572. And 0, well, it doesn't have an opposite because opposite is defined as being a certain distance from 0 in the first place, so 0 is the only number without an opposite. Very lonely. Sad for 0. Doesn't have an opposite. Okay, now put the integers in order from smallest to largest. Now, one way to think of this is using a number line. So the number that would come first, going from left to right on that number line, is going to be the smallest number. So I'm going to, bear with me for a second while I pop back to our number line. Whoops. And I just want to make this point very clear. So for example, minus 10 over here is going to be smaller than minus 9 because it comes first on our number line as we move left to right. So the bigger the value of the digit is in a negative direction, that means it's a smaller number. Okay, so minus 10 is going to be smaller than minus 5. Okay, minus 5 is going to be smaller than minus 1. And then it works and then you just continue increasing in value as you move to the right. Okay, and once we get to positive numbers, you all would be just fine with that, right? So for example, positive 1 is bigger than negative 1. Surprise, surprise. Positive 9 is bigger than 1. Yes, we all kind of knew that. So as you're moving from left to right on that number line, that's helping you to know which one would come first. So of these 6 digits, you want to figure out which one would come first on that number line. And it's going to be negative 300, which I picked deliberately as a really big number here, because it would come first on the number line. Okay, as you're moving left to right. So it is the smallest because the digits are largest in a negative direction. Okay, so it's the smallest. Okay, next, as you move left to right on that number line, you would get to negative 7. Okay, and then as you keep increasing, you're going to get to negative 2 next. Okay, and then you would hit 0. If you recall that number line, you can continue thinking about it as you go. And then from 0, the last two should be fairly straightforward. Next would be 5, and then 22. Okay, so shouldn't be the positive numbers from and 0 as well. So 0 and positive numbers should be fairly easy for you to order. But just remember that for negative numbers, it in a sense works the opposite way. So it's whatever would come first on that number line and then increasing, as long as you're going smallest to largest. If it was largest to smallest, you do the opposite. Okay, now use a symbol, either one of those, to indicate which integer is larger. Okay, so some of these will be fairly straightforward, some of them just a little trickier. Now, anytime you have a positive number compared with a negative number, the positive number is always the biggest one. Okay, same with B. Okay, and anytime you've got just that negative number and 0, then 0 is going to be the biggest one because, again, it's farther right on that number line. Okay, you're having to increase to get there. Okay, D is the same thing. Again, just remembering that when there's no sign, it is implied that it's a plus. Okay, so it's like an imaginary plus sign there. Okay, and no, that's not a T, it's a plus sign. Very beautiful plus sign. Don't mock my plus sign. Okay, so negative 3 and negative 4. Remember, like we talked about on that last slide, as you're increasing, those numbers get, the number that comes first on that number line when you're moving from the left to right is going to be the bigger digit in a negative direction. Okay, so that means the -3 will be bigger than -4. It will be larger because you're moving in that positive direction. Okay, same idea with this one here. So -2 is much closer to 0. It's much closer to those positive numbers than -1000. Okay, on we go. Now the last thing that I have on your sheet, oh, that just went a little too far, is I ask you to include some examples of everyday usage of integers, because these are a thing that you regularly use. You just might not think about it that way. Okay, so on these last few slides, I'll go through them fairly quickly, but I just want to show you some examples of where they're used, and these can also be used again to help understand integers and what we're doing with them. Okay, so I'll use a few of them. I'll talk a bit more about some of them. So one way to think about it is floors in a building. Okay, so you've got your lobby or your ground level, which could be 0. And yes, often they don't have a floor 0. They'll sometimes call it M, but usually you don't have main floor and then 1. Maybe this isn't the best example, but you see where we're going here. So you're moving up above ground level or down below ground level, maybe to get to the parking or the basement. Okay, another one is altitude. Okay, so on this little diagram here, we've got Mount McKinley, which is very high mountain, so positive 20,000 feet. Death Valley in the United States is at negative 280 feet, so it is below sea level. Okay, so these are things that will come up in real life. Okay, another one is banking. If you're depositing money, you're adding to what's in the savings. If you're paying money, you're subtracting what's in the savings. Or if you owe money to somebody, you might say you have negative money because you owe that money to somebody else. You might say you have negative $10 if you owed somebody $10. Okay, now the thermometer is one that I would like to use because it is a regular one in Canada where we throughout our year go well above and well below 0. And it's one way to think of that idea of integers being larger or smaller with them being negative to positive. So for example, say we're at -20 on a cold winter day, and that's we'll pretend that's right there. That looks like a -20. And we'll say we have 0 at this spot. You would say that 0 is warmer than -20. 0 is higher or larger than -20. Okay, and if we were up to +20, that would still be warmer, of course, than 0, warmer than -20. Even if we had +5, we would still say that that +5 was larger than, sorry, you wouldn't say it's larger, the temperature is larger today. You would say that it's warmer because that's what fits with temperature. But you can see how the number, even though the number is smaller, the 5 is kind of a smaller digit without, if you ignore the signs, 5 is smaller than 20, but because 20 is negative, you don't treat it as larger than the 5, you would treat it as much smaller. Okay, so again, please continue jotting down some of these examples of everyday use of integers. And one last one that sometimes comes up is in sports. Football is kind of an example. You can see how you get to the 50-yard line and then the numbers go back down again. And sometimes as you're playing a game like football, you lose yards or you gain yards. Okay, and so sometimes that would be put in as a positive or negative on TV or on the score sheets. So please keep these in mind as real examples because you do use them all the time. Okay, so go through the worksheets that I put in Google Classroom, and we will talk more about integers during our meetings. So please ask me any questions you have then or through Classroom or email. Thank you very much for watching. I hope you're still awake. Have a good day.